Good evening, everyone. I would like to welcome you for today's webinar on artificial general intelligence. This webinar is conducted by none other than our own CSI's co convenor, Professor Mohini ma'am. Ma'am is very skillful in machine learning, artificial intelligence, and big data analysis. Ma'am has completed a postgraduate in big data engineering from BITS Pilani. She is the mentor of TEDxVIT and has a lot of experience in domains of natural language processing, Python programming, and data science. Without a further ado, let's get started.
Okay, good evening, everyone. This is Professor Mohini Chaudhari, Assistant Professor at Vidyalankar Institute of Technology. So, today I am going to speak on the topic Artificial General Intelligence, which I lately came across and thought that I should share it with the viewers. So, talking about Artificial General Intelligence, AGI has, I would like to put it in this manner rather than putting it in artificial general intelligence. I would say general AI. So, general AI has been accurately defined till date, but people believe that they would definitely recognize when it appears. So, it does not has a concise definition as such. In reality, there is a debate over specific examples and use cases, whether they simulate exactly like human brains. And such discussions gets hampered because of the lack of concrete definition of artificial general intelligence. So, since there is no concrete, no precise definition for what exactly is general artificial intelligence, people are not ready to believe in. But then the scientists and researchers, they say that definitely they'll come to know if this kind of machine comes into picture or is invented. So let's start with our discussion on artificial general intelligence. But for that, we first need to understand what is AI. Now, AI, as it was AI, which comes first in this technological world, there is no universally acknowledged definition of AI even, but scientists and researchers defines AI as the simulation of human intelligence processed by machines or rather computer systems. That is, they made systems that would that would process, then interpret, reason out, and then act. So the idea of artificially intelligent beings is prehistoric, with widely recognized references to the intelligent machines appearing as early as the 1300s. Now, this is what, like, while doing this artificial intelligence, the researchers happen to, concentrate on solving specific problems, what is now called as machine learning, which got its start in the 70s or 1700s or 1800s, well before where machines that could learn. And the first actual learning machine showed up in the early 1950s. So there was a need to understand the history of artificial intelligence. So talking about the history, the idea, what I can say, insentient objects coming to life as intelligent beings has been around for a longer period of time. But then the ancient Greeks has myths about robots, and the Chinese and the Egyptian engineers built automatons. The beginning of modern AI as such can be traced to classical philosophers' attempts to describe human thinking as a symbolic system. The first widely recognized work of AI was the design of a Turing complete, that is, artificial neurons in the year 1943. So they came up with the Turing complete, which was then known as artificial neurons. But the field of AI wasn't formally found until 1956 at a conference at Dartmouth College in Hanover, New Hampshire, where the term artificial intelligence was coined by Mr. John McCarthy. But achieving an artificial intelligent being wasn't so simple. After facing several criticisms on the progress of AI, interest in the field and the government funding dropped down, because of which this was somewhere in the period of 70s or in 1974 till 80s, I guess. So this period was called as AI winter. Going ahead from the 70s to directly in the 80s, expert systems brought the field back into vogue. So in the 80s, artificial intelligence developed something called as expert systems. Towards the 90s and 2000, progress continued through the late 90s and early 2000s, which with much wider adoption of machine learning, though AI had become a bad word till then. So from AI, they managed to travel till machine learning, and then it was like when AI was discovered, or when AI came into picture, it was like they wanted the machine to learn like humans and act like humans. But since the learning was concentrated, it then went to machine learning. After the 2000s, in lately in 2011, the current AI spring was heralded by Watson on Jeopardy in 2011 and cemented by ImageNet, DeepMind, Deep Blue, AlphaGo in 2014s and 2015s. So, with this history of artificial intelligence, we would now go ahead with talking something about the frameworks. Now, while AI constitutes to be a very vital part of our lives, one can apply AI into various use cases such as robotics, product recommendation. Every one of us nowadays use Netflix, use YouTube, use Hotstar, use many other such applications which gives you recommendation. We use e-commerce web applications like Amazon, Flipkart. The moment you search for a product, the next moment itself you will start getting recommendation of similar products from other websites also. Predictive maintenance. Daily, we have a stock price prediction, that is predictive maintenance. Audio transcription, your Alexa, Siri, Cortana, they are converting your speech to text. Chatbots. Many applications, many organizations use chatbot. Writing. They predict what you want to write on your email after a particular word, what should be the next word that should come. Voice of the customer analytics, smart images search or analytics. Nowadays, you can not only search in Google through the text, but you can also search through images. Targeted advertising. For a particular type of people, there is a particular type of advertisements. So people who search more for medicines, or people who search more for medicines of a certain kind of diseases, they get such kind of advertises. Nowadays, you have smart search engines, and even we also have autonomous vehicles. The upcoming car models are quite autonomous as compared to the previous car models. So nowadays, the car are well equipped with all types of sensors which can gather data and give a better analytics. I know I'm going more towards analytics, but then it is not possible without AI. or I would rather say general AI. After these use cases, I would like to put some light on the applications of artificial intelligence. Computer vision, voice to text, audio generation, image generation. You can generate an image, natural language processing, natural language understanding, natural language generation. You get text summarization. You use Siri, Cortana, which can understand English language particularly. Natural language querying. Nowadays, we can query anything in the natural language, which is then converted to a SQL query. Recommendation engines, categorizations, anomaly detections. But guys, have you noticed something? None of them are general purpose. Everyone is solving some or the other specific problem. And this is what my point is for the day. I am talking about general artificial intelligence. Yes, I know you might be thinking, what exactly is artificial general intelligence then? Let's talk about it. As mentioned earlier, I told you guys that AGI is not precisely defined technically as such, as a technical term. But then AGI focuses more on the general nature of the desired capabilities of the system. Now, what do I mean by general purpose? Guys, you might have heard about microcontrollers and microprocessors. Yes, you might have. So, what is the difference between the two? Microcontrollers are used in devices which are specific purpose devices, like your calculators, which are meant for doing some mathematical calculations or some scientific mathematical calculations. Your ovens, smart ovens, they are used only for cooking food. But microprocessors, if I talk about, you find them inside your laptop, which is a general purpose thing. You find them inside your mobile phones, which is a general purpose thing. It does all the things. It allows you to make a call, it allows you to send a message, it allows you to edit a word document, it allows you to hear songs, watch videos, and many more things. This is what is the difference between AI and AGI. So now there would be many people amongst you who have heard about or are known to the terms strong AI and narrow AI. You might have heard. And if so, then you might be thinking that what I am talking about is very much similar to what is narrow AI. Is it the same? Am I talking about narrow AI, and am I trying to say that narrow AI is quite similar to AGI? No, not at all. I am not trying to give similarity between narrow AI and AGI. Narrow AI deals with the systems which are explicitly designed to solve specific, reasonably well defined problems. You take a specific problem and you try to solve it by applying various artificial intelligence. But then, if I talk about AGI, AGI is meant to autonomously learn new tasks and adapt to changing environments just like humans. If you are given a new problem and you are asked to solve it, you need not be trained separately all the time. You can solve the problem using your past experiences. You can change to any environment. You can adapt to various changes in the environment. You can apply your own logic and take a decision. Is the same thing done by narrow AI? No, it is not. If I want to give an example for narrow AI, I would then talk about IBM Watson, which is a narrow AI, which is not intelligent enough, which is not prepared for adapting changes in the environment around it, which is not prepared for thinking or from taking his past experiences and then taking a particular decision for a newer problem. Now, okay, that is what is artificial general intelligence. But then, what is this general intelligence? So, if I want to talk about general intelligence, then I would say uh, how can I put it? Okay. Mr. Ben, who is one of the researchers working on this field, defines general intelligence like it involves the ability to achieve a variety of goals and carry out a variety of tasks in a variety of different contexts and different environments. It is generally a generally intelligent system should be able to handle problems and situations quite different from the anticipated uh, by its creators. So if in case purposely some changes in the environment are made or some problems are being created, then the system should be intelligent enough to handle that problem dynamically. He also says that a general intelligent system should be good at generalizing the knowledge that it has gained, and not only generalizing it but also transferring the knowledge from one problem to another. That is what I wanted to say. Whatever your past experiences, whatever you have learned from your past experience, the system should be capable enough that it can take that knowledge from the past experience and could apply on the newer problems it is facing dynamically. Arbitrarily, general intelligence is not possible giving realistic resource constraints. So, real world systems may display a varying degree of limited generality, but are inevitably going to be a lot more efficient at learning some sort of things than others. So, I hope it's now clear what exactly is general intelligence. It's more towards accomplishing variety of tasks with the same robot that you have made. So nowadays there are n number of robots that scientists are making, that engineers are making. A robot to serve in the restaurants, a robot to serve the patients in the hospital, a robot to do specific works in the home, a robot to handle the kitchen. But is it capable of understanding new problems? My robot is trained only to make a typical kind of food or a typical cuisine. But if suddenly tomorrow if I ask him to prepare a continental dish which he is not trained for, will he be able to do the same? No, he won't be able to. Because that robot is meant to solve specific problem. A robot which serves in the hotel or in the restaurants, can it be used in the house for all the things? No, even if you bring it home, it would only serve the purpose of serving the people in the family and not doing anything else. It won't sweep the floor. It would attend the call if you're not at home. It would not prepare a coffee for you. That's it. So, even there is a scientist called Wang who has defined AGI in 5 different manner or in 5 different ways, which are called as Wang's 5 definition of AGI. The first is structure. Now, what Wang says about structure? He said that AI contributes to the study of human brain. But if the research goal is in the behavior, capability, function, or principle of the mind, then to duplicate the brain structure is often not the best way, because the brain is formed under biological and evolutionary restrictions, which are largely irrelevant to the computers. We cannot restructure human brain, or we cannot remake a technical machine which is very much similar to a human brain. Why? Because it is formed of biological components, and not only biological components act into it, but also there are some evolutionary components. There are some things which comes from generations to generations. Next, he talks about behavior. Now, a lot, AI contributes to human psychology. So very often the human way gives us inspiration on how to use a computer, but it is not the best way to solve practical problems or to implement a cognitive function or principle. So also behavior similarity does not necessarily require structural similarity. They both are different. Then he talks about capability. Now there are various applications domain for solving practical problems. However, due to the lack of generality in the solutions, every problem has a different solution. There is no general solution for solving all the problems. So this kind of solution usually contributes little to the study of brain or mind, which is out of the scope of domain problems. It's very difficult to study human mind and maybe replicate it. Is it possible? I don't think so. Because as far as the definition of psychology, every mind has a different key, as every lock has a different key. So for every person's problem, you have a different solution. We cannot have a generalized solution for all the problems of all the persons. So if I consider maybe an organization wherein people are stressed in with work, and everyone is stressed, I cannot come up with a solution which is general and which is applicable to all the people in the organization. Maybe a person could be stressed out due to work, some other person could be stressed out due to financial crunch, or maybe someone else due to some family problem. Will the system be able to solve it? No, the system must have that capability, but then is it possible to do so? Next come functions. So by producing new softwares or sometimes even hardware that can carry out various types of computations, we can come up with some functions. However, the best way to implement the required computations is usually not complex, because you can definitely come up with certain functions which could solve your problem. There are, if you go for programming languages, there are many functions in Python which has solved a lot many problems of machine learning easily. You need not hard code a machine learning algorithm nowadays. You need not hard code a problem to solve something related to natural language processing. You directly get the functions, you directly get the libraries, you just import it, and the problem is solved. But then there are many problems for which you need to make a bit of changes into those functions. So though those functions are generalized, but then they cannot solve all the problems. Still, there is a space for improvement in those functions, depending on different problems. Lastly, Wang talks about principle. So AI computes to the study of information processing in various situations by exploring the implications of different assumptions. And given the generality of a principle, it cannot explain all the details of the human brain or human mind, and nor does it provide the best way to solve every practical problem. So even though a principle based system usually does carry out various cognitive functions, they are not necessarily separate processes, each with its own computational formulations and algorithmic implementations may have a different part, may have a different function to solve a different problem. So these were Wang's 5 definitions. Therefore, these 5 trails lead to different summits rather than to the same one. So every part of it has a different problem, and every part of Wang's definition does not solve a single problem. So now let's talk about what are the various goals of AI. So goals of AI generally are quite similar along with those of AI, which are uh, reasoning, knowledge, planning, learning autonomously. Uh, the only thing over here is AGI is expected to learn autonomously. It shouldn't be an human interference all the time to make the machine learn. So it must learn autonomously. It should have a proper processing of any natural language, and it should have a good perception. But along with all these goals, it also has a goal which says to regard intelligence as a universal problem solver. So, given any problem in this world, the AGI must be able to solve it. It should also be capable of learning to do different things. So, just once it watches someone doing it, it should learn it directly, like humans do it. So no one is knowledgeable or no one is intelligent right from the birth. He learns new things by perceiving something, by seeing people, by reasoning out, by knowledge, by experiences, by perception. And then the human learn. That is how humans do things. And that is how humans solve problems. And this is what is one of the goals of AGI. AGI also requires to learn new things. That means tomorrow, if I bring a robot in my home for doing my home course, and he is trained for few things, and supposedly he does not know how to make a particular dish, so it's just requires me to do or to perform that particular or to make that particular dish in front of the robot. The robot perceives or gets a perception of that dish, and later on, next time onwards, the robot must learn the thing during that process, and he should make it on itself. That is what is expected. So anytime he requires or anytime required, he or she should be able to solve any problem universally. With these goals keeping in mind, let's talk about the capabilities. Now, uh, if I talk about capabilities, then to understand the complexity of achieving true human level intelligence, it is what to look of these capabilities. So without these capabilities, it is very difficult for making a system which we could say is a general artificial intelligence implementation. Now, what could be a machine, or when could be a machine to be said uh, generally artificially intelligent? So it was from the article of McKinsey, which talks about these capabilities of AGI. So the first thing is sensory perception. Now, without these five senses, humans cannot do anything. They cannot see. If they cannot see, they cannot learn. If they cannot touch anything, they won't be able to understand what is the type of the material. If they cannot smell, they cannot understand different fragrances. If they cannot hear, they won't be able to understand or make out. If they cannot taste, they cannot differentiate between various tastes. So, whereas deep learning has enabled major advances in computer vision, AI systems are far away from developing human like sensory perception capabilities. For example, uh, systems trained through deep learning still have a poor color consistency. So, self driving cars are maybe fooled by a small piece of black tape or a red color. Whenever you make a robot to track a particular way, you just give that black color ka ribbon, and it is meant to follow that black color ribbon. What if that black color ribbon is not there? Then what if this red color is not there, and certainly an object comes in, suddenly an object comes in front of the robot? or in front of the car? Will the car stop? Why? Because because the car is not trained to see the red color. That is poor color consistency. Or every time the car sees a red color, will the car stop? Then the car is not trained properly. So for humans, the redness of the stop sign is still completely evident. But the deep learning systems gets fooled into thinking the stop sign is something else. And the current computer vision systems are also largely incapable of extracting the depth and the 3D information from the static images. Now, humans can also spatially characteristics or okay, just understand this. Someday, uh, you call your husband or you call your wife, okay, and okay, we'll consider a situation wherein चुपके से आप एक पार्टी में चले गए. You went for a party without informing anyone at the home. Okay, and you're enjoying. Okay, you're dancing, you're singing songs, and you're listening to loud music. And suddenly, your father calls you. Okay, you pick up the call unknowingly, and you talk to your father. And your father can hear the noise around you, and he can make out that you are not in the college or you're not in the office. You are somewhere else, or you're somewhere partying somewhere. So humans have that capability of listening to the noise coming from the background and understanding which place a person could be. If supposedly you're in a meeting and someone calls you, you talk very softly and there is no noise around. But your soft voice tells that person, yes, you are somewhere busy. There is someone in front of you because of whom, or maybe you're in a meeting. Will a system be able to understand this without being trained? No, you have to train it separately. You have to train it for the background noise also. You have to train it for a silent voice also. Is it possible? So we need the sensory perceptions. Can you say this? Okay, we will talk about. Okay, now you would say that if you talk about hearing capability, you would say that maybe uh, what about Siri then, or what about Cortana? Isn't she a general AI then? Because you can ask her anything and she'll answer, and does that make her a general AI? That would be an obvious question, because you ask her anything and she'll reply to you. But let me tell you, Siri is just a collection of specialized AI. She is not an example of general AI, because what she does is she'll listen to your question, she'll fire the query over the Google, she'll find it somewhere on the internet, she'll match a few words, few keywords, and where she'll find the match, she'll just return that. If you would ask her about uh, alpaca fur, okay, what is the color of alpaca fur? Siri doesn't even know what an alpaca is. Is it a fur or is it a color? And I think a 5-year-old child would be much smarter than Siri. So Siri is not a general AI. What it does is just searching for the queries, searching, matching few keywords, does some type of pattern matching and returns you the answer. Whereas she doesn't know anything about that keywords. She actually doesn't know anything. She is just a collection of some specialized AI. So that is all about sensory perception. Have you seen a robot which eats something? Have you seen a robot which touches something and can understand the touch, whether it is soft, whether it is hard, whether it is thorny. No, that's not possible. Have you seen a robot smelling something? No, it cannot smell. If it cannot smell, how will you make a robot understand? How will you make a system understand that this is a fragrance of a rose or this is a fragrance of some perfume? That's way difficult. Coming to the next capability of AGI, which is fine motor skills. Nowadays, any human can easily retrieve, sets of key from the pockets. Given any of the puzzle, you guys can solve it. Every one of us know about Rubik's cube, which has been solved by a system which implements reinforcement learning to solve Rubik's cube. Very few of us would let any of the robot manipulators or humanoid hands we see do the task for us. But researchers in the field are working on this problem yet. Although like Claude Shannon built a robot to solve the cube decades ago, this demonstration illustrates the dexterity involved in programming robot fingers on a single hand to manipulate a complex objects. This dexterity of our fingers let us know whether a particular thing is soft, it is hard. Every color has a different touch. We haven't ever realized it, but it is. If you go and talk to a blind person, he might be in a better position to make you explain this, because they understand colors through their touch, because their dexterity capabilities are way enhanced than a normal human being. They can tell you what color it is without even seeing it. Just by touching the paper, they can understand which color this is, whether it is red, whether it is purple, whether it is sky blue, anything. So a system to be artificially intelligent in general requires a very fine motor skills. Next comes natural language understanding. So humans have a habit to record and transmit skills and knowledges through books, through articles, through blog posts, and more recently, videos. Like right now, I am doing. So AI will need to be able to consume these sources of information with full comprehension. So nowadays, if you watch a video in Hindi, if you watch a video in Marathi, in English, whatever language you understand, it's very easy. Even nowadays, people watch videos of Korean series. I don't know what, but since my brother does it, I know about it. He does, and then he understands what exactly is going on. Is a system capable of understanding all the different languages? Is the system capable of speech recognition? Many a time, every person has a different accent. The English what I am speaking, maybe a system or a AI system could understand my English because he is well known to my accent. But certainly or suddenly tomorrow, if a foreigner comes and ask him to do something, he won't be able to understand. Why? Because of the accent. Bengali people have a different accent of English. People from the regions like Uttar Pradesh or Bihar has a different way of accent to speak English. Language is same, but the accents are different. And still, if you go for speech to text conversion, many a times your speech is not converted into proper text because they cannot understand your accent. So system also requires to understand natural language along with the accent of the person. Next, talking about the most important thing for which actually we are building AGI is problem solving. If the system is not capable of solving any problem, then the system is meant for nothing. So in general purpose application, a robot will have to be able to diagnose a problem. Obviously, for solving the problem, first he must understand what exactly is the problem and then solve the problem or address the problem. So a home robot would have to recognize that a light bulb is blown. So either replace it or sit and repair it. Or to carry out these tasks, the robot either needs some aspect of the common sense described above, or what I have just said now, or the ability to run simulations to determine possibilities and probabilities, whether the bulb is not working because the electric power is not there, or the the fuse has lost, or the bulb is not in the working condition anymore. The filament of the bulb is broken, and so the bulb is not working. So that is what the scene. Any AGI system must first understand what exactly is the problem. Only then the system could solve the problem or address the problem. If the power is off and if the system takes out the bulb and it starts repairing it, and during that repairing part, if it breaks the filament of the bulb, what is the use? If it doesn't understand, the bulb was not glowing just because the power was off. Nextly, navigation. GPS combined with capabilities such as simultaneous localizations and mapping has made good progress in this field. So, if you want to search anything, if you want to navigate to a certain place, it's very easy through Google Maps. And projecting actions through physical spaces, however, it is not far advanced when compared with the current capabilities of the video games. So, in order to make a system understand the navigation, maybe what could be done is the real life places could be given to the system virtually, as that of PUBG or what that game was, certainly game Pokemon Go. When students or when youngsters used to play that Pokemon Go, what was the basis of that game? It used to locate your nearby area. Okay, so that is how the system is understanding what is there nearby. So system must be, the current academic demonstrations have not come close to achieving this goal of navigation. So maybe I could say years of work would still be required for achieving this goal. Next comes creativity. Now, creativity is certainly what I feel is not a thing which could be taught to you. There are no classes for learning creativity till date. I don't think so. A person is creative on its own. Some person are creative, some are not. Some like to follow the rules and some like to break the rules and come up with something very new. Is the system capable of it? Since it is a system, every time we are calling it as a system is meant to do something systematically. That means to follow some rules, some regulations. Will the system break the rules and do something creative? Is it possible or not? So it is something which talks about super intelligence and would theorize at once AI reaches human level intelligence. It will rapidly improve itself through a bootstrapping process to reach levels of intelligence far exceeding uh, to those of any human. It's very simple. Just giving an example. Uh, there was a my ME project, and I was certainly doing emotion extractions out of a given text. And I generally happen to give this example to all my students when I teach them machine learning. Is that uh, many of us, or rather, all of us, have heard the story of Cinderella. And I happened to ask this question to my guide, that there was a sentence wherein it says that torturing Cinderella was her stepsisters enjoyed doing that, but she used to be nervous. Such kind of sentence. I don't remember the exact sentence, but then given the sentence to the system, what would be the answer? That time, I remember what my guide had said. She said that, Mohini, you are making a system. You're not making a human. A human, depending on the point of view, he would decide whether this statement is a sad statement, or is it a happy statement, or is it a nervous statement. That totally depends on the point of view of a person. If the person is thinking from the point of view of the stepsisters, definitely for that person the sentence would be happy, because the stepsisters were happy torturing Cinderella. But if a person is sympathetic towards Cinderella, and if he is thinking from the point of view of Cinderella, then the system would say no. The sentence over here is pointing towards the nervousness of the system. So this is the answer. So I think systems are rather meant for following rules as such. So for a system to be generally intelligent or generally artificially intelligent, the system should be able to implement creativity in what it does. Will a system be able to do something like this, which is right now seen on the screen? This is something very abstract. No answer. Next is, last but not the least, social and emotional engagement. Every person is socially or emotionally engaged somewhere. Maybe with the parents, maybe with the friends, maybe with the partners, maybe with the soulmates. For robots and AI to be successful in our world, in the world of humans, uh, they must watch humans how we interact, or rather they must interact with us. The systems must interact with the humans and not fear them. The robots will need to understand humans interpreting facial expressions, or changes in the tone, and uh, maybe that reveals the underlying emotions. Sometimes when I'm fearful, maybe I won't speak a word. Or sometimes, like, if I am angry, I would shout at someone. So the pitch of my voice would tell, or the facial expressions of mine would tell that I'm angry. So certain limited applications are in use already. There are certain applications which could understand your facial expressions, your gestures, and make some output, or make some inference that whether a person is angry or sad or happy or worried. But given humans' own difficulty interpreting emotions correctly and the perception challenge, AI that is capable of empathy appears to be a distant prospect. Even we humans many a times make mistakes in understanding a person, in understanding a person's facial expression, in understanding what a person wants to say or what a person is going through. बहुत बार हम लोग अपने दोस्तों को, इवन अपने पेरेंट्स को समझने में गलती कर देते हैं. Though they are not angry with us, but then we think that they are angry on us. So with these difficulties, AGI would only be possible if all these capabilities are adapted by the systems. So it must have a sensory perception, it must have fine motor skills, it must have problem solving capabilities, it must understand the problem and then address it. It must also process natural language, it should understand natural language, it should generate natural language, it must be capable of navigating anywhere, it must be capable of creativity. And not only this, but the most important, it must be capable of adapting to the social and emotional engagement. So, coming towards the end of the session, I would like to talk something about the applications of AGI. So, from 2010 till 2014, till the last application, in the previous slides, we talked till 2011. Let's talk what have come up. 2010 to 2014, AI had something related to deep minds. They came up with deep minds, which develops Q learning algorithms to beat the Atari games. Many of you might be well known with the Atari games. So Google buys DeepMind for $500 million. The next, in 2014 exactly, AI came up with AlphaGo. DeepMinds, which was previously captured by Google, which was previously bought by Google, begins development on AlphaGo in 2014. And AlphaGo is trained on 30 million professional moves and thousands of matches against itself. Next, in 2015, AlphaGo beats one of the top Go players in the world, Lee Sedol. 4:1 was the score. And before playing Lee Sedol, AlphaGo's learning mechanism was turned off. Was it still a machine learning program? It's a question till date. Coming to the 2020s, there was a rise of robot children. Robots were used to teach children of primary schools. There were cartoon robots which were made. You guys have seen movies like Metallica or Transformers. Even when we were kids, there were a cartoon called as Transformers. The car used to get transformed into a robot. And again a car back. All that was what? Though it was a fantasy, but somewhere they were trying to show us the future. We didn't realize it. Again in 2020, there was a rise of AI scientists. That means what they did was animal or childlike AGI was combined with useful narrow AI to make virtual AI scientists. Wasn't that amazing? That means we are not trying to even make a human, we are trying to make a AI scientist which is virtual in nature and which would then lead to maybe AGI. So guys, with these applications, I would like to end my session for the day. I hope you guys have enjoyed what is AGI, known to what is AGI, what are the difficulties that could be done or that could be faced while making a system which could be said to be artificially generally intelligent. All the things that I read were from these of the references. So, thank you everyone for listening to me so patiently, and I hope that I had definitely uh, enlightened you with this topic of AGI, which is not that famous, but lately I came across it and thought of sharing it with all my viewers. So, thank you everyone. If there are any questions, welcome. The host could forward me the questions if any.
Thank you, ma'am, for such a wonderful webinar. A gentle reminder: the link to the feedback form has been put up in the comments below. So make sure you fill the form to get the certificate, as the feedback link will be up only for an hour. Thank you for attending.